So cloud, mobile, basically if you look at a large proportion of the apps that are currently in Marketplace, they're all focused around the sort of the consumer experience. And that's really good because it means that they're super simple to build because quite often they're focused around consumption of data, okay? Now, historically I've come from sort of an enterprise background, so I've done a whole bunch of work around enterprise sync, so getting data from back-end systems onto the client so they can go off into basements and stuff like that and still have data available. With the advent of Windows Phone, there was a big push by Microsoft to focus around consumer, and of course consumer meant, you know, big name brands getting data onto the phone, displaying flashy tiles and stuff like that. Okay, most of that stuff you can do without having to think about the complexities of data sync. Okay, unfortunately, as we go forward, those problems start to emerge, particularly as we're now back into the enterprise. So Windows Phone 8 has now got a full raft of enterprise features, which we'll cover later today in the enterprise session. Which means that it's actually a really good tool. And if you look at the 520 and the price point around that, you've got all of the features of the high-end devices on a device that's sub $200. Okay, so as a fleet device, it's awesome, and you can do a ton of stuff from a developer perspective to make sure that you can get data from your back-end systems out onto that device. So the focus of today's session is really about talking about data from the point of view of designing your app, all the way through to storing data locally on the device, through to connecting to the cloud, okay? And whilst there's no built-in support for synchronization, we'll look at some basics around synchronization and the ideas that you need to think about if you're going to synchronize data down to the device so you can have that data available offline. Okay, so the scenario that we're going to go through today is about defect capturing. Okay, so imagine that you're out there, you're going to take pictures of, you know, potholes in the road, or it's not a very inventive scenario, granted, but it's marginally better than the to-do sample, which comes off Windows Mobile Azure Services by default. I didn't want to do that demo because everyone's seen that one to death if you've been tracking across Windows Mobile Azure Services. So I came up with a permutation, which is about defect tracking. Anyway, so the idea behind a defect is that you're out on the road, you're basically going to take a photo of the defect, you're going to put a title or a caption on it. You want to specify a defect type, so it might be a pothole or it might be a fallen tree, and you're going to measure the severity of it, okay, so scale of 1 to 10, okay. So we're going to have this concept of defect types, okay, so we've got two tables already, we've got defects and a defect type table, okay. And the caveat that we've put in here is it must work offline. Okay, so at the end of the day, I should be able to synchronize, go completely offline, so basically flight mode, and still be able to capture defects. At some point in the future, I'll go back online and be able to synchronize those changes back up to the cloud. A little bit of an overview of the architecture we're going to be building. So we've got the phone in the middle, okay, that's pretty key to everything. We're going to be using Windows Mobile Azure Service just as an example of the services in the cloud that we're going to use, right? So I've picked those because it's actually relatively easy to get up and running. It does connect through to our SQL Azure backend, but you can imagine this could be any of your internal systems, okay? We're just using that as an example of the types of backend services you could be connecting to. We're going to use blob storage for storing the photos. Okay, so as you're capturing on the photo on the camera, we're not going to be sticking those in our SQL Azure table. We're going to stick them into blob storage. That gives us a number of benefits. Firstly, it doesn't mean that it clogs up our SQL Azure database. It means that we're not paying for additional megabytes there. It also means that this blob storage ends up on the CDN, okay, which means that data access is going to be particularly quick for dragging down those photos. And you get a ton of stuff like compression and things like that out of the box with the CDN there as well. On the client side, we're going to use a combination of isolated storage for when we capture the image with the camera. Okay, it's got to go somewhere. And if we're thinking in an offline scenario, we've got to write it to isolated storage directly. And we're going to be using SQLite. So we're going to be using that for our offline database. And so what we're going to aim for is a model that looks like a bit like this at the bottom. Now let me walk you top to bottom. So this is the client-side structure of our app. So basically, if you saw my presentation yesterday, you'll see the separation between our view, which is our pages, and our view model and model. We've basically got a really simple app. It's got 2 pages. So we've got a main page, which is going to list our defects, or the defects that we've currently captured. And then we've got an add defect page. So that's where we're going to be capturing the photo, entering some information, and then we're going to hit save, and we're going to go back to the main page. To go with those, we've got the corresponding view models. So those are going to represent the current states of our pages. And both of those are going to connect to a single repository. And the repository is where most of our work's going to be for saving and loading defects and defect types. Behind that, it connects through to isolated storage and SQLite. And what's interesting here is I've actually put this off to the side here. So this is the Windows Azure mobile services. Originally, when I did this diagram, I actually had that connected to the repository. Okay, the problem there is that actually we shouldn't be thinking about it that way. We should be thinking that these two are almost connected in isolation from everything above it. Okay, so we shouldn't care when or how frequently the synchronization between SQLite or the database on our client and the cloud happens. Okay, the idea is that you're going to separate that as an abstraction so that you can call sync. You know, at some point in the future, it will come back and say, yes, I'm done, or no, I failed, and we won't go into this today, or conflicts were raised. Okay, so because you might have multiple people both working on defects. As they get resolved, all of a sudden you end up with this concept of conflicts because, you know, two people could be working on it. One's going to say, okay, well, it's done, and the other one says, no, it's not. Somebody's got to work that out, right? And the only people who can do that are customers of the app, so the people using the app. So you don't want to be stuck with resolving that on the server side. You somehow need to bubble that back up to the client. We're not going to delve into that today, but it is something that you will need to consider as you start to do synchronization. Today, we're actually going to stick with a very simple model, which is defect types will synchronize down to the client. Okay, so as I add them on the server, they'll be pulled down incrementally. Defects themselves are going to be pushed up. So as I create them on the client side, they're only going to ever go up. Okay, we're not going to do a full synchronization of the defects. And that immediately gets rid of any sort of synchronization challenges, okay, because you're not having to deal with multiple people accessing the same record at the same time. Okay. And this is where my slide deck ends, because, well, it doesn't actually end. There's a ton of other slides that are here that you can download after it, but in all likelihood, we're not going to get time to come back to the slides to walk through them. They're really there so that at the end of the session, you can go, okay, well, hang on, what was he talking about, or what were the main highlights of the session, right? So the first part we're going to do in terms of building this app is we're going to do some design time data, okay? And with that, I'm going to exit out of PowerPoint, and we're going to drop down into Visual Studio, where I've already created us a vanilla Windows Phone project. It's called Defect Capture. And actually, the first thing we're going to do is actually create that second page. Okay, so we've already got our main page. I'm just going to go ahead and create our defect page. And from here, we're going to switch across to Blend, and we're going to start to design out our application. So we've got our main page here. Now we're going to start off with some design time data. Okay, I've got a rough idea of what the data is going to look like. So I will go ahead and actually create some sample data that's going to mimic that. So this is going to be our main page data source. Now what you'll notice here is that actually my design time data will actually aligned with my pages, my view models, and now I've got design time data. Okay, so I've seen a number of, and this particularly happens if you start working with the designers, because they'll go, okay, I'm going to go and create one set of sample data, okay, and I'm going to use that across my entire app, or I'm going to use it for these particular pages, but then I'm going to create another one for these pages, and all of a sudden it gets really messy because you go and change one thing on one page and it changes everything everywhere. I find it much simpler to, and actually what designers end up confusing themselves because they think, oh, hang on, I don't want to change this. Oh, I'll just add another property or another set or another set. So in actual fact, if you can keep them paired with the pages, it's actually easier for the designers. How many designers have we got in the room, by the way? One. And you're sort of one of those designer developer people, though, aren't you? Yeah, okay, so if I have a hard time or give designers a hard time, you won't get offended. Good. Shane will give me a hard time later. That's all right. Okay, so in our main page data set, we're going to have defects. And the first property here is going to be our title. And the second property here is going to be our photo. And I'm going to actually change the type of this design time data from a Boolean to an image. Now, if I look at the sample data that it generates a bunch of chairs. Probably not that relevant, so let me just switch down and go to a different folder. So I've actually got this folder. It looks like it's empty, but it's basically not. It's got a bunch of images that have got pictures of defects. So now if I actually look at that, you'll see that it's a bunch of potholes. And I can go and customize the title and things like that. Now I mentioned a couple of other properties. So we're going to have defect type, and we're also going to have a severity. And the severity, we're actually going to make a number. So I can go in and populate that with that. And it's actually not going to be a number of two places. It's actually going to have one, because it's going to range from 1 to 10, or 1 to 0 to 9, as the case may be. So let me go and have a look at that. Okay, so that design time, other than the defect types and title not is being random text, it's starting to look okay. Let me go and create the design time data for my other page. So I'll do new sample data for add defect page data source. And we're going to have, here we're going to have a collection of defects. Defect types, because we're going to actually allow the user to select from a list of the defect types. So we're going to synchronize those down from the server. They'll actually be available from in a list picker for them to pick between. So I'm going to give that a name property and actually get rid of the other property here. So this is my collection of defect types. The other property that I'm going to have on this add defect page source, and remember I'm going to use data binding for all of this information that we're going to be collecting from the user. We're actually going to create a new complex property, and this one's going to be our new defect. Okay, so it's a single item, and it's actually going to be made up of all of those properties I just created in the main page. So we've got photo, which is going to be an image, and we're going to have a title. Have a severity, and we'll have a defect type in there. Okay, so now we've got that, let's actually go and start designing out our page, and I'm going to change this to have a title of defects, like so. I'm going to go back to my main page data source, and I'm literally going to drag that across onto here. So let me just do that again in slow-mo. As I drag it across, you get this tooltip, and I apologize, you probably can't see it at the back, that says, create a list box and bind its item source property to defects. Okay, so it's going to do a ton of stuff for us. Drop it on there. It's actually wired up this data source as the data context for this page. It's created me a list box. It's set the item source property, so basically the property that defines where the items are going to be sourced from. And it's going to be setting that to this defects property. Okay. It's also created me an item template, and what I mean by that is for each item that's going to be in my collection, it's defined a layout for that. Okay, so here I'm going to actually do a reset layout all, and you think, oh, isn't that going to throw everything everywhere? What it does is it basically takes, you can see here that this list box has been constrained in height and width, and it's been positioned on the page. I don't want that. I actually want it to take up the available space within this container. Okay, so I go reset layout all, and it's now taking up the full space. For those who saw that it expanded all of a sudden, that's Control 0. Okay, it basically allows it to auto zoom to the right size. Very useful shortcut. I don't particularly like this layout, so I'm going to actually go and change that. So I'll go edit additional templates, item template, edit current. And you notice I actually get the designer support for actually laying that out now. So it's basically selected the first one up there, allowing me to drill in and rearrange it. I don't particularly like the fact that it's a stack panel, so I'm going to change that. I'm going to go change layout type to grid. What you'll notice behind the scenes is actually Blend is going to jump in and actually start to put heights and widths on things that you don't want. So you actually need to get rid of those by going reset layout all. And every time you do a layout change or something in Blend, you get used to doing reset layout all. So we'll actually see that a couple of times through this part of the demo. We're going to have 3 columns in this grid. Okay, so I'm going to sort of change the layout slightly, and we're going to do columns. There are a couple of different ways to do column layouts or grid layouts, and depending on what your preference is and how you find things. My preference is to go into the column editor and go 3 columns, each one. These first 2 are going to be auto-sized, and the last one I'm going to leave to be star, so it's going to take up the remaining of the space. I'm going to click OK. It really hasn't changed my layout that much, but what it does mean is that I can now position things in those columns. I'm going to go to my assets window, and I'm going to grab a border. The reason being is that at the moment we've got our severity listed as a number. Okay, it's listed as 5. Okay, I don't particularly want to do that. What I want on this home screen is actually to show whether a defect is high severity or just a regular defect. Okay, so what I'm going to do is actually have a border that's going to sit there. It's going to have a background color, and the background color is going to either be, we'll pick blue, for example, for a low priority defect, or it's going to be red for a high priority one, okay, or high severity. And so this border, I'm going to actually put it it's going to be in row 0. I'm going to, again, reset layout on this, and I'm just going to set the width to 20, And just for the time being, I'm going to actually hard code that to the accent color. Okay, it's not positioned great because all of my content is actually in that first column of the grid. So I'm actually going to move things across into the other columns, and then what we should see is that that border will actually sit right on the left-hand side. So let me do that. My image I'm actually going to put group into a grid, and I'm going to basically reset the layout on both of those, and you'll start to see it starts to maximize a little bit. This grid I'm actually going to constrain to 150 by 150, and I'm going to position that in column 1. And this image, I'm going to change the stretch to uniform fill, which means I'm always going to see 150 by 150. Things are just going to be stretched uniformly, but to make sure it completely stretches out over that space. So this is going to handle when I'm getting images that are going to be rectangular, either portrait or landscape. It's basically, you end up cropping the information off the sides, but it ends up meaning that you've got a really nice alignment in that main page. Obviously, when you click through to it and look at the details of that defect, you wouldn't want to be cropping stuff off. But when you're presenting things in a nice, funky list, then you have to make some sacrifices. Okay, so this is going to be there. So that's in our second column at the moment. What's remaining is these other text boxes. Now, I mentioned that we're going to use the severity for the color of this, so I can actually get rid of that text block. The other two text blocks, I'm actually going to go group into stack panel, so it's going to group them like that. I'm going to put this stack panel into column 3, so index 2, and now it's appearing alongside them. The other thing we're going to do is somehow we've got some height set on a stack panel, so I'm going to reset layout on those, and things are starting to align a little bit now. On my grid, I'm actually going to put a 24 pixel margin on the bottom, which is going to give us some space between our items, and I'll indent it by 12, and that's going to bring things in line on the left-hand side. So all of a sudden, we've got some nicer layout. The last thing I'm going to do is actually these text blocks. Firstly, they're in the wrong order. I actually want them the other way around. Again, you can see in the XAML at the bottom here that they've actually got fixed heights on them. So again, I'm going to reset layout on those. And the first text block, I'm going to make a regular style. So I'm going to set this to normal. Okay, so I'm making sure that I use the built-in styles. The reason being is that my app is designed to work with the system colors, so it's going to be switching between dark or light theme based on the user's choice. So if I don't make use of the styles, then all of a sudden I'm going to stop seeing some of my text when they switch the style on me. I'm going to use the subtle style for the defect type, and that's pretty much what our list should look like. Okay, so actually this is a pretty bad example of some sample data, so let me just go in to modify that slightly. If I modify that, here's the thing. Okay, so my sample data is actually not bad. What I've forgotten to do is actually forgotten to wire up my sample data to this red border along the side. So let me go and do that. Now the problem is that the border color here is a color, and what I've got over here is a severity, which is a number. Okay, so I'm going to need to do some sort of conversion between the two. And that's where value converters really come in. So I'm going to switch back to Visual Studio, because Blend's not really good as an editor. I'm going to view code in here. And you don't really want me to type this out, so I'm going to drop this value converter in here. And I'm actually going to move it into a separate file by itself. Just using ReSharper. Okay, so here's our value converter. So you'll see here that it's called a severity to color converter, and it's an I-value converter. And essentially what an I-value converter is, it has two methods. It's got a convert and a convert back. We're not going to use convert back, so I'm just going to return value out of there, just in case it gets called. By default, the implementation throws a not implemented exception, which I don't think is a really good policy, because it's just going to bomb out if you accidentally call it. But the focus here is basically on the convert method, and what we're going to do here is work out whether the severity is above or below 5, and either return high priority color or low priority color, and these are actually marked as properties on this color converter. So let me switch back to Blend, and what we should see is that we should be able to pick those up in Blend. Let me just do a quick build to make sure Blend realizes that I've added stuff to it. And what we'll do is click on our item and go into the item template. Go to our border, go to properties, and where we set the color, I'm actually going to set that to create data binding. Common mistake is that often when you come in here, this checkbox is here which says only display matching types, and notice our severity is not in there. I'm not exactly sure why strings are a background color. I guess that if you return red, then it's going to do the intelligent thing and convert it to a color. But if you uncheck that, you get all of the other properties, which includes our severity. Down here, I'm actually going to pick one of the converters, but I haven't actually got any instances of this converter created in my application yet. So I'm going to go ahead and add value converter. It's going to pick up the fact that it's going to basically iterate over through my assemblies and basically look for I-value converters. And in this case, I'm going to select the severity color converter. So that's when I select that, it's going to go and create an instance in code of that. And I'm going to click OK to wire that up. Now you'll notice here that it's immediately dropped the background color, and that's because by default my severity color converter actually doesn't have those two attributes set to define or to return the colors. So if I open up the XAML, just go to the top here where it's actually dropped the severity color converter into the XAML here. I'll just do high priority color can be red, and low priority color, high default and low priority color. And what do we settle on? We settle on blue, I think. Right. Okay, so our designs actually started reflecting that information. Okay, so that's page number 1 done. Let's go to page number 2. Okay, so here, let me again go to our data page. And I'll go new defect. And we're going to drag this new defect onto here. But we don't want, this isn't a collection of items, right? So if I drag it on in the current mode, it's going to try and do intelligent things around it being in a list. Okay. Actually what I want is I actually want it to be in details mode. So up here at the top, you've got this switch between list mode and details mode. And now when I drag on individual items from here, it does intelligent things like gives me a single instance of an image. Again, we're going to do the same sort of thing we did in the previous page, so we're going to group that into a grid. We're going to reset both of those. We're going to specify some heights and widths on these things, so 200, 200. We'll position them top left, like so, inset by 12. So I think we've got some alignment there. Our image, we're going to do a uniform fill together. I'm really not happy with that design time data, so let me just quickly change that to this folder as well. Okay, so we've actually got something that looks sensible. Now to fill in the rest of the blanks, what I need to do here is I'm going to need to input title, severity, and defect type. So defect type I'm going to be inserting using a list picker. So I'm going to basically use my defect types and populate a list picker so that the user can then select those. Severity and title, we're going to use a regular text box. So for both of those. So I'm literally going to drop those on. But before I do that, I'm actually going to change this grid to being a stack panel because I want things to stack vertically. So stack panel, and I'm going to start to drop in a text box. And let me just reset layout again. Okay. Blend has this annoying habit of trying to be more intelligent than you are. Right, okay. It just undid all my hard work. There we go. Okay, so text box number 1, text box number 2, and actually what I need to do is actually include the list picker. And the list picker is actually in the Windows Phone toolkit. So let me switch back to to Visual Studio. And I'm just going to add those from NuGet. Manage NuGet. We're going to do Windows Phone toolkit. We'll install that. And actually, to save me coming back in here later, I'm going to add the Windows Azure mobile services as well. We're going to use those in a little bit. The mobile services add quite a few things to your project. Okay, so one thing you do need to remember in Visual Studio, when it adds a ton of stuff, it doesn't always save the solution file, which means that when you flip over to Blend, Blend doesn't necessarily remember or work out that you've changed stuff. So if you do Control-Shift-S before you switch back to Blend, it just means that everything, including your solution file, gets saved. Because the last thing you want to do is go back to Blend, add a few more things, and then for it to clobber those changes that you just made in Visual Studio. Okay, so what we should have here is the list picker. If I now pick that up, and I'll just drop that into there, and let me just put it into the stack panel. And Blend's done its funky thing of positioning it again. So let's just put it into the stack panel itself. Right, so it's appearing at the bottom. Okay. We're actually going to put a header on this. So one of the properties that comes with the list picker is a header. So I'm going to put defect type. And in theory, I should go and put titles on these two things, but I'm going to be a bit lazy today and not put those on, just for the matter of time. Let me squeeze down here, and we're going to data bind these things up. Now, you'll notice down the bottom, we've already got the data context set on the page because we dragged on the photo earlier. I can go either from this window or from up here and drag on the relative items like that. And we'll do severity, and up here we'll switch back to list mode and pull the defect types down onto our into our list picker. Okay, the one thing I do need to do is also go and add some app bar icons, and then we're pretty much done from the design perspective. Okay, so I'm going to add two of these on this page. Okay, the first one is going to be to save, and we'll grab the right icon for that. It's down here somewhere. And then the other one will be for camera capture, doing the camera capture. I'll call that camera. And that's down here as well. He says, sorry, I'm going blind there. Okay, let's go back to main page, and we've got to do the same here. So let me add some app bar icons to there. So I'll add two of those. The first one's going to be an ad. So that's going to open our ad page. And then the second one, which we'll use later, is going to be for sync. And let's see if my eyes can see the sync thing in the list this time. There it is. Okay. So the only one we actually need to wire up at the moment is going to be the ad. Let me just double click on that. We'll go to the event window, and we'll do sync, click. I misspelled that, but not that important. Okay, and now we're back to Visual Studio. Okay, so let me go to that page. And not that page, main page, view code, and we're just going to add some code into there to navigate to the defects page, right? So basic navigation operation to the URL of the add defect page. I'm just going to run it up at this point just so you can see what our app's going to look like and to prime the emulator. Okay, so we've got a list of defects, and if I go add, then we've got a defect with design time data, including a list of those. Now, the gotcha here is I didn't specify an item template for when it's in full screen mode. I'm glad I demonstrated that. If I go back to blend, it's a relatively straightforward change in here to basically use this. So when you drag on that collection of items, it's generated an item template for the items that are actually in the list there. But the list picker works in two modes. If you've only got like 3 or 4 items, it actually drops down in situ. If you've got more than that, it actually goes to the full screen mode. So what they've generated for you is actually just the template for when it drops down in situ. If you want to go to the full screen one, then you basically need to change the other template, which is this edit full mode item template. And actually quite often all I'll do is I'll use exactly the same item template that's been used for the drop down. Okay, so if you look over here in the item template, it's actually set to this defect type item template. So I'll set it to be the same one here. Okay, and that will fix that problem. So when we go to full screen, we'll actually see that. Okay, the other thing I'm going to do while I'm back in Blend, you notice that when I ran it up in the emulator, it's got design time data. We probably don't want that at runtime. And what I would have glossed over earlier is when I actually created a new set of sample data, it has this option to enable sample data when application is running. Most of the time when I'm creating an app, I'll leave that checked by default. Okay, I'll go and do the first pass of my initial design. The advantage there is that you can actually use it, you can basically run up your app and actually see what that page is going to look like in the context of your app. Of course, as you get closer to production, you want to disable that. You just go back here and uncheck the option against this data source. So I'll do that for both of these, because as we go, we don't want those to be interfering with our code. I'll go ahead and save those, and now when I run it in Visual Studio, what we should see is we should see an empty list and an empty add defect page. Okay, awesome. So what's next? Let's go and actually create some real data. Okay, so in order to show some real data, we're going to need a defect. Okay, so this is my defect, and you'll notice that I've got Now, what's interesting here is I've got two different IDs. I've got an ID that's actually going to be required by mobile Azure services. They do require it to be called ID, and it does need to be an int. Okay. Now, because I'm doing synchronization, I've also got a unique ID. And the reason for that is if you're thinking about using integers as your primary ID, it sucks for doing synchronization, okay? Because you can't uniquely identify a record that the client has created unless you go negative and then work out some sort of resolution when you post it to the server to get a real ID, okay? Unless you separate off a chunk of IDs for the particular client, and then it gets really messy, okay? So generally, when we started to talk to data sync, and it's interesting because I'm really in contact with the mobile Azure services team, and they're going, yeah, it wasn't a great idea to use ID, ints as the primary ID, was it? I go, no, it wasn't. So they're probably gonna look at doing something around GUIDs for when they roll out some sort of synchronization. So in this case, we're going to have a unique ID, which is actually a GUID. It's going to be a string in this case. We're going to have a title, a defect type. We're going to have severity and a URL for the photo. We're also going to need a defect type. So let me just drop that into there. This primary key, I'm going to leave it commented out for the moment. That's when we're actually going to need that when we start to use SQLite. Again, it's got to uniquely identify those. And you notice that for the defect type, I actually don't have a unique ID. I'm just going to use the ID generated by mobile Azure services, because as I described before, defect types will only ever come down from the server. So they're not going to be created from the client, which means I don't need to deal with that synchronization issue. Let me just push these out to separate classes so we don't pollute this file. Okay, and so the next thing we need to do is actually start to wire up our pages with our view models. Now, because most of our view models need this implementation of iNotify property change, I'm actually going to create a base view model, and it's also going to have this concept of a repository as part of this base view model that my two view models are going to inherit from. Currently, my implementation of a repository looks a bit like that. It's got nothing in it. Let me separate these again into separate files just to make them easier to find. I did warn you there was going to be quite a lot of code. And so now what we've got our repository. Okay, it doesn't actually do anything, but we're going to fill that out in a minute. We've got our base view model. What we need is the two implementations that are going to be out for our main page and our add defects page. So we'll do our add defects page first. Okay, relatively straightforward. It's got those properties that we declared in our design time data. So we've got a new defect, and which is a defect object itself, and we've got a collection of defect types. Okay, so an observable collection. I've made it an observable collection rather than just an array, so that when we get to the page, and the initial incarnation of this will actually go off to mobile Azure services when we get to that add details page. So this is our sort of connected model. Okay, it's going to go off and pull those down, and by making an observable collection, it means that when I've got that data, I can then add them to that collection, and they'll be reflected in the UI. The other view model we need is our main view model. So I'll go ahead and create that. And that's only got a single property, which is our list of defects. Again, it's an observable collection to mean that we can add and remove items and it will be reflected in our UI. Again, let me just switch these out to separate files. Okay. The next thing we need to do is actually create an instance of them. Okay, so as we get to each of those pages, we somehow need to create an instance of the view models. We need to wire up an instance of the repository, and we need to serve it up to the individual pages. And to do that, we're actually going to make use of a view model locator. Okay, so again, it's relatively straightforward code. We're not doing anything complicated here. I don't subscribe to any of the dependency injection frameworks that can do this type of thing, because I think that for most apps, it's kind of overkill when this is literally all you're going to end up doing for the dependency injection framework, is basically creating an instance of your view model, assigning a bunch of properties to it, and then serving it up to the page. Okay, so we've got a repository of which we're creating a new instance as we create the view model locator. And then we're serving in properties up that expose new instances of those view models. So for those who sat through my talk yesterday, I've got a very strong association between a page lifecycle and the view model lifecycle. So in this case, if I was to repeatedly go back into the add defects page, I'd get a new instance of the add defects view model. And that means that it's very closely associated with that page. To wire all of this stuff up, I'm obviously going to need an instance of this view model locator, and I actually do that in XAML. Okay, so I'm going to go into my app.xaml file, and under resources, I'm actually going to create an instance of that view model locator. So XAML is just a markup for actually creating instances of objects, and I'm going to give that a key. So x key, we'll call it locator. And so this locator object is now accessible both within my code, so I can get a reference to it. It's available in the XAML, as we'll see in a second. It's also available in Blend. So even if I didn't have any of that design time data, by the virtue of the fact that I've got this locator here, when I start to wire it up in the main page, all of a sudden Blend will actually realize that I've got it wired up to those data objects, okay? And it will automatically give me some ability to do design time data, even if I don't actually go and manually create those design time data. So to wire it up to the individual pages, all I go into is into the pages. I go data context. I'm going to do a binding, and I'm going to do binding to the main property. So you'll remember back on our locator, we actually had a main property and we had an add defect property. So, and of course we're going to have to reference that property on something. So we do source equals static resource locator. Oh, not localized string, locator, like that. And we do exactly the same over on our main defects page. Add defects page. And so we go add defect. Okay, so that's our data context. So now we've wired up both the main view model and the add defect view model. Okay. Now, if I run this, hopefully it won't bomb out, but we won't see anything anyhow because we've got no data being surfaced up in those. Awesome. Let me just delete that. For those who worked with the emulator, sometimes you get these quirky little things where it needs to uninstall it. Okay, so it's working. It's actually assigning that view model. Of course, we've got no data. So that's the next task. Let's come back into here, and we're going to have to go back. We're going to start in our repository, I think. Sorry, actually one more thing we're going to do before that. We're actually going to, in our code behinds for these pages, quite often what I find easy is actually, I'm not a big prescriber. I don't go down the path of doing command binding. So quite often for events and for click-throughs and stuff like that, I'll actually have like 1 or 2 lines in my code behind, passing the control back through to the view model. And to make that easier, I'm literally going to have a snippet of code, which is in the add defect page. I'm going to have a property called view model, which basically means I can access the current view model on the page from any of my code in the code behind. I'm going to do the same in my main page. XAML.cs. I'll just drop this code out as well on there. And that's just going to make accessing those that much easier a little bit later on. Before we actually go into the repository, which I was going to do, and actually start to pull down data, of course I've got to pull the data down from somewhere. So let me switch across to mobile services. And I've already created an instance of a mobile service to save us a little bit of time. So it's called TechEd Defects v2. The important thing that we're going to need is we're going to firstly need to access the mobile services. Now, we've already pulled down the NuGet package. In order to access it, they've already given us the snippet of code that we need to do that, right? So this is basically the singleton that you can have within your app that will basically give you access to all of the APIs that are on mobile services. So let me go to my repository. So if you remember from my initial diagram, that's where I'm going to do the majority of my work. So I'll go to there. Actually, let me just move this view model locator out to another file so it doesn't clutter up our repository. In our repository, we're going to have an instance of our main service client, our mobile service client. So I'll add the using statement there. And you'll notice that it's wired up to the URL of our mobile services and the application key that I need in order to access it. Now, what's interesting here is that we'll see in a minute when I'm going to use Fiddler, I can actually go and use both of that, the URL and that access key to write HTTP methods myself to actually access mobile services. So mobile service is primarily just a REST-based API that this mobile service client basically wraps and gives us a nice UI or a nice set of APIs to work with. So let me flip back to mobile services. I'll show you the data structure that we've got. So we've got a defect and a defect type. What's interesting about these is actually they've only got a single column called ID at the moment. Okay, and the reason for that is we've currently enabled what they refer to, I think it's dynamic schematization, or it's a funky word like that. Basically means that as I start to throw stuff at it, it will go, if I throw it a new column, like name, it'll go, oh, I don't have a name column. Hang on, I'll create you one. So it allows you to basically rapidly build out the structure of your application without having to worry about going into SQL Management Studio and going, I need a new column. Okay, so it makes rapid application development that much easier. Of course, when you go to publish your app, you might want to turn it off, because if somebody sniffs your endpoint, all of a sudden they're going to go, I can send you a whole bunch of columns that you didn't have before, right? So you end up with 1,000 odd columns that you never realized existed. Okay, so not a good thing. So let's actually go to, so we've got defect and defect type. I'm going to show you quickly how we can access this content using Fiddler. So if I go to my compose window, I've already got it pre-populated. So this is the URL up to there. So that URL is the same URL that you see in here. Okay, all I've done is put on the end of it tables, so basically all of your tables that you've got in there, and then defect types, so the name of the table that you want to access. I've also included the key, so remember this is the same key that you see in your app, as a header in here called Xumo application. And you think, well, where the hell does Xumo come from? That was their code name for the whole product. And somehow it managed to get into the API set and they haven't been able to remove it. So it's one of the header items. If I actually request that, because I've got no records in my database at the moment, you should see it come back in a second, hopefully. There we go. And it comes back with an empty JSON object. Okay, what we can also do is actually go ahead and actually start creating them. Okay, so I can go here and change this to a post. Same table, okay, so I don't need to put anything on the end of it. And down in the request body, all I'm going to do is specify the shape of my JSON object that I want to pass up. So name, what are we going to say, pothole. If I could type. And I'll go execute on that. And we should get a 201 back, which basically says it's been created. And what you'll actually get back here is actually the fully created object. And for those who are quick off the mark, will notice that we've got an additional property there. We've got ID, we've got name, and we've got a last updated. I'll come back to last updated in a little bit, but basically that's to make sure that we can support incremental downloads. And I'll show you how that gets injected when we get to doing the synchronization bit. Let's go ahead and actually add another. Damn, I just hit the wrong button there. Let's go and compose and add a different one into there. So let's just go fallen tree. Let's go ahead and execute that one. And so we should have another one there. And now if I actually go back to my original query and execute that, what we should get back is two defect types. Now let's flip back to our application. I guess I can show you in the console as well. So I'll go refresh on there. I'll go to defect types and show you those. Okay, so you can access it the same way through the portal. The portal's pretty full-featured. It basically gives you a lot of capabilities around being able to view the data. And also if you want to reset tables and truncate them and things like that, you can do that through the portal. Other than that, you can do them through Fiddler, or there's also a command line interface for doing a lot of this stuff as well. So that's another way of accessing all of this information. So let's go back to Visual Studio. And what we're going to do is we're going to write some methods to actually access that. So if I go to my add defect page, okay, when we actually get to that page, we're going to write some code to basically to go ahead and actually load that information pull those defect types down from Windows Mobile Azure services. So what we're going to do is override the onNavigate2 method. My code snippet already had that, so I'll grab that. And we're going to call the load method when we actually go off to actually arrive at the page. Call load method that currently doesn't exist. I'll go ahead and create that one. And this one here is basically going to go var def types equals await repository dot load. I think it's defect types. Actually, I'll call it load types. And that method doesn't exist yet either. And so we'll go ahead and create that. And now when I'm in here, I'm actually just going to replace that with my snippet, which does just that. And so you'll notice that one line I've basically called get table. So basically the table, you pass it in the type of the table. Okay, so behind the scenes, the mobile client's going to basically do a conversion between that and the name of the table. Okay, so there is some naming convention going on there. And all I'm doing is calling toList on those. Now, if you have massive tables, obviously don't call toList on them because you'll end up getting either all of the records or you'll get a subset and it's been filtered on the client side. So you do need to be relatively smart about that. In this case, I'm just going to pull this data for the time being using that method. Let's go back to here. So that's going to follow through. Let me just check that I've got that all wired up. Okay, so That's going to pull back the defect types through the repository. Of course, I then need to populate my actual defect types object. So defect types clear for each of those defect types add defect type. And so what we should see is if I now run this, as we go through to add, within a second or two, we should get our list of defect types. Okay, so that's just pulling the stuff straight from Mobile Azure Services. Okay, so you can see immediately that Mobile Azure Services makes that type of thing quite simple to do. It gives you a lot of the client-side code that you need to write for that as well. Now, of course, we need to start populating our new defect. So I'm going to go to our defect page, and I'm going to start to wire up a couple of other things. Okay, the first one is going to be, back on the page itself. I'm going to find our list picker. And when the user changes the list picker, I'm actually going to go ahead and actually set the defect type on our new defect. So selection change, defect type selection changed. Okay. And again, you don't really want to see me type all of this. So basically, I'm going to pull out the selected item, and I'm actually going to specify the defect type just as a string literal actually on that. And you might be thinking, why are you not data binding that? Okay. The reason being is that list picker is one of those objects that actually doesn't data bind particularly well and doesn't do two-way data binding particularly well. The main reason of that is if you've actually got a short list, it works fine. When you actually get a long list and it pushes out to a separate page, all of a sudden you run into a bunch of issues where it doesn't actually come back and update the property properly. So it's one of those areas where I do handle the event and I go and set it myself. Okay, again, one of those reasons why command binding might not necessarily work for you. The next thing we're going to do is actually capture an image from the camera. Okay, so in order to do that, I'm actually going to drop out the constructor, mainly because it's in my code snippet. I'm going to drop in a code snippet that will reference the camera capture task. Okay, so essentially this code creates an instance of the camera capture task. I do that in the constructor, and you notice here that I wire up the event handler in the constructor. Okay, this is important because of tombstoning. For those who've done a history on Windows Phone, you'll understand that tombstoning happens if your app goes into the background and there's memory contention. The framework will decide that it's going to drop your application out of memory. And then when the user presses the back button, eventually it will get rehydrated and reloaded. Okay, and at that point, you've got none of your existing instances in memory anymore. Okay, so you do need to be aware that that still happens. It's still a problem, particularly if you're targeting those low-end devices like the 520 or 620. Okay, so you do need to make sure that the event handler does get wired up as part of that constructor. The logic for this is basically when we get back from the camera capture task, we validate that we've actually got a camera image or an image from the camera just by checking that the task was okay. We're going to get a reference to the local storage, check if the file exists, delete it if it does. Okay, so that allows the user to go and make changes to it if they need to, and then go ahead and open the file and basically write out the file, which comes back as a stream, into isolated storage. Now you'll see, okay, well, this local photo path doesn't exist, so let me go and create that as a read-only property. Okay, and again, I've got this wonderful snippet here because there's a bunch of things we actually need to do here. Local photo path. Let's add in all of this stuff. And you're going, isolated storage stream, okay, we're doing quite a lot of stuff there. So this is our local photo path. We're basically using that unique ID again. So essentially a GUID.jpg, it's going to be the local image, okay? Relatively means it's going to be relatively unique. It means that each new defect we're going to create doesn't overwrite the previous one. We've got a refresh method that actually refreshes or triggers the on-property change on this photo property. Okay, so when we first get to the add defect page, the image is going to look for this photo property because that's what we data bound it to. Okay, it's going to look for it. It's at least going to find it now because we've actually defined the property, whereas we didn't before. We had a photo URL. As part of that, when we first come in here, it's got no URL. Okay, so there's nothing defined. And so essentially it's going to return nothing. Okay. When we actually go and create the image or we capture the image from the camera capture task, we're going to be writing it to disk. Now the problem with writing to disk is when we then have to serve it up to the image, we actually need to access that as a stream. And you'll see here that we're actually manually creating the bitmap image and then serving that up to the image. Okay, so this is how we serve up local images. And obviously once we've actually made the upload to the server, then we can actually reference it by the actual fixed URL. Okay, so that's all the sort of the legwork we need to do to support both the cloud-based approach, so pulling it down from blob storage, but also the local approach as well. Okay, so let's go back to our repository, and we're going to need a method in here that's actually going to save our new defect. Okay, so essentially we're still accessing the mobile services table, okay, and we're just calling insert with the defect. Okay. So let me go to our add defects page, and of course I then need to wire that up to our save method. So click, save, click. And we're just going to call viewModel.save. Of course, I've then got to make that async. We'll go ahead and create that method. And the method that we're going to call on the repository, surprise, surprise, is going to be save defect, and we're going to pass in the new defect as such. Okay, so now we should be pretty good to save that. We're also going to go back to the main page and actually load some defects. So let's go back to our repository, have a method for loading them from the web. Okay, so that's going to pull back our list of defects. Of course, we then need to write that code into our main view model. So we'll have a method here called task load bar defs equals await repository.load current defects clear for each defect in there, defects.add defect. Okay, so that's basically going to populate our view model. Okay, of course we then need to call this method, so let's just go back to our main page, go in here, and we'll go override on navigate to viewModel.load, and again it's async and await. So with a bit of luck, we should have some joy when we run this. So we're going to add. Of course, I didn't actually wire up the camera click event there, did I? So let's go back to our add defect page. We're going to go down here to the camera. We'll do click equals camera click. And all we're going to do here is the camera capture task that we created earlier, we just need to call show on there. Okay. There's a bit of wiring up logic that I omitted there. So let's try that again. Add new image. We'll go camera capture task. This is the emulator. It actually does return an item there. So this is going to be our new item in here. The test. Let's put an item in there. We'll make sure it's a fallen tree, and then we'll hit save. And I'm assuming that did save. I'm assuming I actually wired that up as well. Let's go to our client and actually have a look. And we have our record there. First part of the demo worked. Okay, now for those who are astute, you will notice that I didn't upload to blob storage. Reason being time, I'm just going to move on and we'll come to actually wiring it up the proper way, and we'll do the upload as we do the synchronization, because realistically that's when you typically do it. Okay, so what we now need to do is actually come back into Visual Studio and unwire all of that stuff we just did to wire up all of the stuff as we go through to the add defects page, and actually move that into a synchronization approach. So we're going to come down here. To do synchronization, we're going to need to use SQLite. So there's a bit of work we need to do to actually set that up. So let's go and firstly add a new project. We're going to add a class library called SQLite core. And it's a class library. And actually, the reason I'm doing this is because if you include the SQLite-net NuGet package, which I'm about to do, if you include that in your main project and you've got sample data that you've generated in Expression Blend, you end up with a naming conflict. And for the purpose of this demo, I don't want to spend half an hour trying to debug that in preference of showing you some other stuff. So I've actually put it into a separate project. Typically, I would normally position this stuff along with my view models. And actually, most of this stuff I'd end up putting in a portable class library. Again, for the purpose of this demo, I haven't done that. So let's go and add in the relevant NuGet package. Okay, so we'll look for SQLite-net. We'll install that into this project. Now, if I was to go and build that, you'll find that it doesn't build for a number of reasons. The first one is that because we want to use the native implementation of SQLite, I actually need to copy this compilation condition into the properties of this project, build. Make sure you set this to all configurations, because otherwise you'll do it in debug and then wonder why your app breaks in release. All configurations, and put this flag in there. Okay? So what that's going to do is it's going to go looking for the native implementation of SQLite. Okay? The other thing we need to do is actually reference the native implementation. So it will go add reference. If I go to Windows Phone, you go to extensions, you'll see there's SQLite for Windows Phone in there. And the other thing I need to reference is actually a library that does basically a link between the native implementation and the managed world. So I'm going to go add existing project, and the link for this is this whole project is actually going to be in the slide deck, so feel free to grab it afterwards. Don't worry about trying to copy it down. I'll add that project in as it stands. Okay, so it's a C++ library that basically exposes a number of nice endpoints for us to access. So there's one more link that I missed in the SQL core, which is I'll go back into there, add reference. Now I'm going to reference this SQLite implementation that I've got there, and now this one should build successfully. I think I just made myself my own worst enemy. Let's just check that I've got that build configuration. I think I just did what I said that I shouldn't do. All right, all configurations. Save that. Let's rebuild that. Okay, so that's building, which is good. And now from in our project, we're going to go add reference solution SQL core, and we should be good to go. Okay, so let me close this project down. And what we're going to do is we need to now start to initialize our SQLite database so we can start writing records to it. Okay, so we've done all of the legwork to actually create a reference to the relevant projects. We just need to create an instance of our database in our application. So in the same way as we created a singleton reference to our mobile services, we're going to do the same in our repository. So I've got a method called initialize in here that's going to create me a SQLite connection. Okay, and you'll see here that I've just passed in the path to a defects.db. Okay, you can call it whatever you like. It doesn't really make much difference. The only significant part is that I've combined that with the local folder path. Okay, so this is essentially isolated storage, but what you actually get out of here is actually a file reference. Okay, so it's file : whack, 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 and then the appropriate folder, as opposed to just an isolated store reference. Okay, I've got initialize method, which basically goes ahead and creates two tables. Now, actually, it will only create them if they exist. So it's a relatively safe thing to call multiple times. So I can call this initialize method every time I start up my app. And I've got a reminder here to remind me to to restore the primary keys on my two items. So let me come back out to here and restore the primary keys on there and on my defect type table. Okay, and that's going to allow me to basically save those and restore them back and delete them from my local database. The other thing I need to do is, of course, actually call that initialize method. And so what I'm going to do is I'm going to go back to my view model locator, where you'll remember I created my instance of my repository, and I'm just going to call repository.initialize at that point. Okay, so that's going to go ahead and create me those. The next thing I need to go is back to my repository and replace those load methods. So instead that they're loading from the cloud, they're now going to load from the local storage. Okay, so back to my repository, back to my load methods, so load types. Let me just comment that out. Load types. We'll do the same with my save defect. So we'll actually call save defects, and this time we're just doing a local insert. And we'll do the load current defects as well. So comment that out, put those into there. The other thing I'm going to do is, of course, we now need some methods in our repository to actually do that synchronization logic. So whilst my initial diagram had, the SQLite connecting directly to Windows Mobile Azure Service, of course, you've got to inject some code to actually do that. Okay, it's not going to magically happen for you, not yet, anyhow. So let me go and add some logic in there to do that. So basically, this is a method that does sync defect types. So you can see here that it's going to connect to our local table. It's going to pull out them ordered by last updated. Okay, so remember we saw that last updated flag appear in the defect types. And if there is none in there, then it's going to just return a minimum value. Okay, and then it's just going to do a get from our mobile Azure services. So it's then going to insert them all into the local database and return from there. Whilst I'm here, I might as well add the sync defects method, okay? And this does a similar sort of thing, except it's doing the other way around, okay? So it's basically going to connect to our local table. It's going to pull back, it's going to access the mobile services table. It's going to go ahead and upload our photo. Of course, I'm going to add that method in a minute. It's going to insert the record into the mobile Azure table. It's then going to delete it from the local table. Okay, so let me go and add that code. So this is what we need in order to upload a bunch of stuff. And while I'm in the process of adding stuff, I will add these two last things into here as well. I will make this code all available afterwards because there is quite a lot of code, particularly when we start to look at the this cloud blob uploader. It's basically a class that I use quite often to upload large blobs of things back up to the cloud. I think it's now been superseded by a NuGet package, but I haven't got my head around the new NuGet package to do it. So that's been relatively new stuff. But I've used this class quite a lot, and it's nice because it actually gives you some progress stuff as well. So if you're uploading a large thing, it'll actually break it down into the blocks, give you a progress indicator along the way to basically as it goes through the upload process. So particularly good for giving feedback to the user. And it does the whole block approach, so at the end of it, it actually does a put and makes sure that those blocks are all aligned at the end as well. So let me just check I've got all my references. So that's the cloud blob uploader. The other thing this upload photo method does, I do apologize, I'm jumping around the code a little bit here. So this is the method that gets called by our synchronization process. So we're doing the synchronization, we're doing upload photo there. This upload photo makes use of that cloud blob uploader, so that's actually going to do the uploading part. But in order to do that, what it actually needs is a read-write token to actually access the blob storage, because we don't want to give vanilla access to everyone, because of course that would mean that we get a ton of stuff in blob storage that we don't really expect. What we're doing is we're actually going to get a SAS token, which is basically going to give us a short-lived access to a particular container within blob storage. To do that, we're calling this load upload SAS object, and we're literally calling an API on the mobile services called getBlobAccess. So I'll quickly flip over, show you what that API looks like. So this is one of the new features they've just added into mobile services. Prior to this, you really only had table accesses, so you could do your standard, read, write, update, those types of things on tables. And if you wanted to have any custom methods up there for just doing some logic, you actually needed to write those as part of a get operation or a read operation or an insert operation onto like a virtual or a mystery table. So they now support this API model where you can basically go and define custom APIs. And they do need to be either a get or a post or one of those HTTP actions, but that's going to be pretty typical anyhow. So you'll see here that this one, which is called getBlobAccess, it's a get operation, so basically exports.get. The name of this function is actually the name that you see here, so getBlobAccess. And you'll see that this basically goes through the process of creating a short-lived token to access blob storage. Now, I won't walk you through the code. I will make it available afterwards. But because the access token, like the main access key for blob storage is stored on the server somewhere, and of course, somebody needs your password to get into the portal in order to access it, it's relatively secure, okay? Having that access key available on the client is a recipe for disaster, okay? It's possible, but it's a recipe for disaster. Okay, so we're pretty close to being there. So we've replaced all of the methods. The only thing we really need to do is actually wire up the sync method in here. So find sync. Okay, and so we're going to do click. If I could still type. Create that method, and we're just going to call await repository.sync, and we're going to do defects types first, and then we'll do await repository sync defects, and then actually we're going to call the load method on this view model at the end of there as well, because of course we'll be updating the list of defects that we've currently got on the page. Now I hope you all pray to the demo gods. Okay, so obviously not. Object reference not set to an instance, right? So we don't have a key on there, key on there. Let's make sure I've got a reference to the SQLite project or the extensions in my main project. Well, that's a good sign. At least we've got something there. Let's go ahead and create a defect. And this is our new defect. And we'll do a fallen tree. We'll hit save. We'll go back. Okay, it's there. Pretty good. Okay, we'll go back into there. Cross fingers it's there. Synchronization. Done. And that's back up in the server. Let's just check that I'm right on that one. New defect. Voila. If you don't believe me, hopefully the blob is now in blob storage as well. So if I do a refresh here, there it is. So somebody was praying to the demo gods, it all worked successfully. So there you go, you have end-to-end design all the way through to actually local access through to synchronization to the cloud. So there you go. Right, so we've got all of about 7 minutes. Feel free to ask questions. Let me just, so if you do want the bulk of this is all aligned in here, so let me just skip to the end. There is some related content going on the rest of today. So questions?
Notice you're using all the asynchronous methods. Is that the new thing for Windows 8?
Yep, I use async await virtually everywhere. So some caveats here. How many people are familiar with async and await and use it regularly? Okay, so there's a big gotcha if you're new to async and await. It's designed primarily to make sure that things work asynchronously nicely in the background whilst not blocking your user experience. Okay, so things like file access and calling services, okay, it works really well for those. And by default, the framework will offload it onto a separate task and will not block your UI thread. However, if you randomly use async and await through your code and you are under this false illusion that it's going to separate your calculation that you're just iterating through numbers from your user experience, you're sadly mistaken. Okay, it doesn't work like that. What it does do though is it means that you can do task.run and run that stuff on a background thread whilst not blocking the UI thread. So if you're going to use async and await, I do encourage you to go and do some reading, do some experimentation around it, because quite often people will start using it and wonder why their user experience is still jerky and still blocking, okay? It's not a magic recipe to unblock your user experience. It does work out of the box with platform stuff, so basically file access and service calls and those types of things. But if you're going to use it for your own asynchronous operations, you need to make sure you use task.run to actually invoke it on a separate thread. So that's the equivalent of thread.new worker thread, basically. So.
This is a quick question. I haven't started Windows 8 yet, but I still with Windows 7.
Yep.
And I start using Windows Store 8, and you got the problem with the the UI thread is single, and then you got a sync which you want to update
the UI thread.
Right?
Yep.
And the workaround for the Windows Store is to use UI dispatcher.call. Does it have the same problem, the same call for Windows 8?
So actually, Windows Store has less of a problem around updating the UI thread. It's actually it's better than Windows Phone. So Phone 7 and Phone 8, you still need to use dispatcher.begin invoke to get back onto the UI thread. But if you use async and await, 9 times out of 10, you get away with not having to flip back and forth between threads yourself, because task.run will do that for you. So basically, you can do task.run, have your block of code within that, a lambda, or sorry, as an expression. You basically iterate through those. At the end of that, you automatically end up back on the UI thread to go to the next statement. That is the nice part of async and await. It means that you're not continually jumping around in your code. There's still circumstances where you do want to actually literally pass things off to a background thread, and then you will need to still call in dispatcher.begin invoke. The biggest issue with the dispatcher.begin invoke is you can't call it from a portable class library, and so 99% of your code now should be going towards portable class libraries. So it will mean that, so we're doing a project at the moment that is Phone 7 and Phone 8. We get probably 60 to 70% code reuse between those libraries just because you're using portable class libraries. And if we extended that out to Windows 8, again, we get that same level of reuse. And so all of our view models are almost identical. So TechEd that they've just announced, that's at the high level, it's a UI on each of the platforms. Below that, portable class library, and so we do that for all of that stuff. So there are some issues if you're going to do it across mono. There's some compatibility challenges there. So because it's still so new, it's definitely still in the embryonic phase, even from Microsoft's point of view. It's stabilized probably only over the last month or so in the Microsoft space, because they've done so much work to support it for async operations, for even between Phone 7 and Phone 8. Up to about a month ago, you couldn't really use portable class libraries on Phone 7 because there was no support for things like async and await and those types of things. So yeah, it's come a long way in a relatively short amount of time. So, other questions? All stunned, all asleep. Yep.
Just summarising the session. So, as you launched, you went and grabbed data from Windows as well, populate different types.
So I actually made it a manual approach to actually force the sync in order to get the defect types. What you'd probably do in a real app is basically look to see if you've got any defect types, and if you don't, then the first operation would, and you'd probably put some sort of loading indicator to the user to say, hey, this is your first time, I'm going to go off and get your defect types. And you may separate the logic out there as well, so it may be every time you synchronize it, every time you launch the app and they've got a network connectivity, you go looking for new defect types, but then you only ever upload existing or new defects when the user hits the sync button. So the actual logic there, and one of the reasons why I've actually separated the two sync blocks in the code is so that they can be called independently at different times. Okay. One of the other projects I'm working on at the moment is a little bit more challenging because we're doing synchronization over probably 10 or 15 tables that have got relationships between them. This is a very simple example of synchronization. In that case, we are using mobile Azure services, but the relationship and the challenge we're facing is, of course, we've got to work out how we filter things because we've got a relationship from the user down to table 1 to table 2 to table 3, and we don't want all of table 3 just so that we can show 2 records, right? What we want is the appropriate records from table 1, the subset from table 2, and then the subset from table 3. And that becomes a real challenge because mobile services was never really geared to do that, to have that relational support. So it's definitely something that they acknowledge as it's a limitation of mobile Azure services at the moment. But behind the scenes, it's just SQL Server, right? So if you want to go and put those relations in your database, and actually the best way of doing it, of doing that filtering, is on a table level. You basically, in the scripts and code behind for the reads, you can actually call SQL. Okay, so you can literally call the SQL based on the current user ID to filter off to the right records. So. For sync, it's all my own stuff. Okay. Yeah. So the only stuff I did for NuGet around that was the SQLite references. And if you're going to go down that path and use SQLite, I would encourage you to throw me an email because I'll tell you exactly the steps. It wasn't particularly clear there because I jumped through it very quickly. So.
There's a better way to implement that because I saw you actually downloaded a SQLite net and then grab the code in there. Actually, if you download the extension of SQLite version 3, you don't actually need to do that straight in there, and you can compile the RT window straight away because we've done that.
And that works for phone?
Yeah, beautiful.
Okay, I'll double check it. The last time I checked that, it wasn't working for phone.
I think that's like half a month ago. They released a new version.
Aha, good.
We actually stuck in there.
Yeah.
Final resolved the problem.
Okay.
Have you ever used the sync framework?
Yeah. The Microsoft one?
Yeah. How do you feel about that? Because that's an interesting topic with syncing relational data.
Yep.
So we haven't done that, but we're sort of thinking about are we going to be using this? I don't know whether you.
Yeah, so I've been through multiple incarnations of Microsoft Sync. So back in the days of Windows Mobile, we had RDO and merge replication, and those are the only enterprise-grade sync solutions that I've really seen. Going from there, we then saw ADO.NET sync services, which was okay in kind of a Mickey Mouse approach. It would be great for this demo because it was all WYSI. So it was basically you drag and drop stuff and you say, I want to sync this table to this table, and it basically generated the code that you need to include in your app. From there, we saw Sync Framework, and Sync Framework tried to be everything to everyone, right? And it didn't do a good job of anything, but it was the next iteration of ADO.NET sync services. But literally, it was trying to sync everything from feeds through to, if you remember, there was a whole big motion around feed sync for a while. So Sync Framework tried to incorporate that, and it tried to do a lot of stuff. It kind of stagnated when they went to try to get Sync Framework 4 out, and they really haven't. They released that as a CDP, and I don't know whether they've even published it officially. So.
I'm thinking about using a different on the back end, including the SQLite and locally actually can configure that way.
Yep.
I'm also thinking about, in relational search, because potentially in our project and company, we're facing the same issue that you got. Searching for those relational, we try to minimize the payload, not get all the data back.
Yep.
Thinking about, has anyone actually done those things by using the Sync framework?
Yeah, so Sync Framework's pretty comprehensive, and it will work, but you just do need to get your head around the entire thing in order to get even a simple example up and running. So that's the challenge there, is that there's a lot going on, and it's just really, it's over the top. And it does, from what I remember of it, it actually relies quite heavily on syncing with SQL Server, because it uses change sets and stuff like that. And I don't even know whether they've got a SQLite implementation of it yet.
You can actually tweaking the data context by yourself to point to the SQLite. There's quite a lot of flow.
Oh, are they? Okay, cool.
Yeah. Just haven't tried those things with Azure yet.
Yeah. Okay, cool. All right, well, thanks very much for coming, guys. I'm around for the rest of the day, so feel free to come have a chat. So. Sorry?
Where can you find the code?
So the code I will put on my blog. I'll actually regurgitate this as a blog post. So probably the easiest thing to do is grab my business card, go to my website, which has actually got a link to the blog.
I need one.
Again, don't you get one every year?
Yeah, still.
You guys want one?
You come up with an elaborate one every year.
What are you after?
That whole thing.
The whole thing?
Yeah.
Wait until I publish it on my blog. Because if I give you it in this form, it won't make any sense to you.
Just have a look at the blog.
Are you gonna publish?
Talk to you maybe in the future.
Okay, cool.
Done something cool.
Yeah.
Probably just borrow the idea.
Yeah.
We might be facing the same problem.
All right, cool. Yeah, no, I'd be interested to see how far you go with the Sync Framework stuff. So let me just grab some cards for the people who still want them.